In this lesson, you will learn what Revit architecture is and how its parametric change engine benefits you and your work. You first begin with the fundamental concepts on which Revit architecture is built. You will then learn the terminology, the hierarchy of elements, and how to perform some common tasks in the product. The Revit architecture platform for building information modeling is a design and documentation system that supports the design, drawings, and schedules required for a building project. Building information modeling delivers information about project design, scope, quantities, and phases when you need it. In the Revit architecture model, every drawing sheet, 2D and 3D view, and schedule is a presentation of information from the same underlying building model database. As you work in drawing views and schedule views, Revit architecture collects information about the building project and coordinates this information across all other representations of the project. The Revit architecture parametric change engine automatically coordinates changes made anywhere in model views, drawing sheets, schedules, sections, and plans. The term parametric refers to the relationships among all elements of the model that enable the coordination and change management that Revit architecture provides. These relationships are created either automatically by the software or by you as you work. In mathematics and mechanical CAD, the numbers or characteristics that define these kinds of relationships are called parameters. That is why the operation of the software is parametric. This capability delivers the fundamental coordination and productivity benefits of Revit architecture, which is change anything at any time, anywhere in the project, and Revit architecture coordinates that change through the entire project. For example, let's say you want the outside of a door frame to be a fixed dimension on the hinge side from a perpendicular partition. If you move the partition, the door retains this relationship to the partition. Another example of a parametric relationship would be windows or pilasters spaced equally across a given elevation. If the length of the elevation is changed, the relationship of equal spacing is maintained. In this case, the parameter is not a number, but a proportional characteristic. Another example of a parametric relationship would be the edge of a floor or roof related to the exterior wall, such that when the exterior wall is moved, the floor or roof remains connected. In this case, the parameter is one of association or connection. A fundamental characteristic of a building information modeling application is the ability to coordinate changes and maintain consistency at all times. You do not have to intervene to update drawings or links. When you change something, Revit architecture immediately determines what is affected by the change and reflects that change to any affected elements. Revit architecture uses two key concepts that make it especially powerful and easy to use. The first is the capturing of relationships while the designer works. The second is its approach to propagating building changes. The result of these concepts is software that works like you do without requiring entry of data that is unimportant to your design.